Okay. All right, I finally got myself figured out. Today, while I'm not here, I want you guys to review the distributive property. I say review, but I haven't taught it to you this year. This is something you should have learned in 6th grade. It's been 2 years maybe since you've learned it, and this is a really important skill as you move into algebra for 9th grade. So before you actually go to 9th grade, I want you to have one more opportunity to review this. The distributive property just means you are distributing one factor to, in a multiplication problem, to every term inside of another factor in that same multiplication problem. So here we have 4 times the quantity of x plus 3. So we're distributing the 4 in the multiplication with x, and we're distributing the 4 in the multiplication with 3. This would be like if I handed a stack of papers to a classmate and said, can you distribute this to everybody in class? They would pass a single paper to everybody in the classroom. The operation that we're distributing with is multiplication. So we've got 4 and x being multiplied. We have 4 and 3 being multiplied. This is a positive 3, so we're going to have a plus here in the middle. Okay, well, 4 times x is just 4 x's, and 4 times 3 is just 12, and that was plus. Now, I've got 4 x's and 12 constants, so I can't combine this any further, which means I'm done. And that's it. So looking at another example, I have the term negative 8 being distributed to x and being distributed to negative 3. So I'll have negative 8 times x. I'll also have negative 8 times 3, and this was over a minus sign. A subtraction sign separates the x and the 3. So I've got a minus sign separating those two portions of my new expression, or my equivalent expression. So now I'm multiplying and I have negative 8 times x. Negative 8 times x is just negative 8 x's. And then I've got negative 8 times 3. Negative 8 times 3 is negative 24. And there was a minus sign separating the two terms. So we have negative 8x minus negative 24. There is a more efficient way to write this, because we know that negative, or minus a negative, minusing a negative really means positive, or adding. So we can rewrite this as negative 8x's plus 24. Okay, next we'll look at number 3. I meant number 5 because I'm going down the page instead of sideways. So looking at number 5, I actually don't have a number that I see with my eyeballs in front of the parentheses. I don't have any numbers outside, but I do have a negative sign. This is saying I have negative of the expression 2x minus 7. That would be negative 1 single 2x minus 7. So negative 1 2x minus 7. Negative 1 multiplied by the quantity 2x minus 7. So we're going to take the negative 1, and we're distributing this to 2x's, and we're distributing this to 7, and we're distributing this over a minus sign. So I've got a negative 1 times 2x's. I have negative 1 times 7, and this was over a minus sign. Okay, well, negative 1 times 2x is going to be some number of x's. Negative 1 times 2 is negative 2. So negative 1 times 2x is negative 2x's. We just did the math and ignoring the x for now. And then we multiplied negative 1 times 2 and got negative 2. Next, we've got negative 1 times 7, and negative 1 times 7 is negative 7. And then this was distributed over a minus sign, so I'll have a minus between the two terms. I cannot combine negative 2x and negative 7 because one of them has x's and one of them is plain number constants. But I can rewrite this because we know minus a negative really means to add. If we're getting rid of negatives, we are making something more positive. So this will be negative 2x plus 7 for my final answer. Okay, now I've got number 7. Now this looks a little bit different. Remember, we can multiply in any order, though. This is, do not write this that I'm about to write in pink. But you've got 2 times 3 is 6. Well, 3 times 2 is also 6. And that will work with any multiplication problem you have because you can multiply in any order. That's something you proved to yourselves in 5th or 6th grade. I can't remember which. This means, though, that the quantity 6x plus 9 times 3 is the same as 3 times 6x plus 9. So the distributive property works even though the constant was on the right side of the expression instead of in front of the parentheses on the left side, because I can multiply in any order. So the same concept applies. We're distributing the number 3. I'm sorry, I'm neurotic and need that to be read. We're distributing the number 3 to the term 6x and to the term 9. Okay, so I'm going to have 3 times 6x's. Okay, and we're going to have 3 times 9. And the operation that separated the two terms in the first factor was in plus sign, so we'll be adding those two terms. Okay, we've got 3 times 6x's. This is just 3 groups of 6x's each, so I'd have 6x in the first group, 6x's in the second group, and 6x's in the third group. So I'd have 6 and 6 and 6, or 18 x's. Essentially, you're just multiplying the two numbers, because I can multiply in any order, so instead of doing 6 times x first and then times 3, I can do 3 times 6 first, which is 18. So I'll have 18 x's plus 3 times 9 is 27. Okay, I cannot break that down or combine that, simplify that anymore because 18 x's is a variable term and 27 is a constant term. They're not the same type of term, so I cannot combine them. Okay, next I'll go to the even numbers now. The even numbers, we've got the quantity of x plus 5 times 5. We have 5 x plus 5 things. So I'm distributing the 5 to both terms x and 5. So I'll have 5 times x. I'll also have the 5 from the outside of my expression, the second factor 5 times the 5 on the inside of those parentheses. Okay, I've got, and then we were distributing, there was a addition sign separating the two terms in the first factor, so we'll have an addition sign separating the terms, the two separate terms after I distribute. Okay, so we've got 5 times x, which is just 5 x's. We have 5 1x's, so 5 times 1 is x. 5 times 1 times x is just 5 x's. And then 5 times 5 is 25. This was over a plus sign. I've got 5 x's, a variable term, and 25, a constant term. I cannot combine those, so I'm done now. I have this as simplified as possible. Now we're looking at number 4. We've got the 2 on the outside of the parentheses being distributed to both 2x and to 3. So I'll have 2 times 2x's. I'll also have 2 times 3. And we were distributing the first factor 2 to an expression, to another factor that had the terms separated by a minus sign. So I'll have the two terms after multiplying separated by a minus sign. Okay, so I've got 2 times 2x, or 2 times 2, which is 4x's, minus 2 times 3 is 6. I have an x term and a constant term, so I can't combine them anymore, which means my final answer is 4x minus 6. This just means that, and I haven't explained this in all of the other problems, but what we're saying is that the expression that we started with and the expression I've written here are the same. They're equal. For that matter, the part where I'm showing my work is also an equivalent expression. These all three mean the same thing, but it might be easier to see something written like 4x minus 6 as opposed to seeing something written like 2 times the quantity of 2x minus 3. It also might be easier to communicate 4x minus 6 as opposed to communicating 2 times the quantity of 2x minus 3. So those are the reasons why we might use the distributive property. Okay, looking at number 6, my goal is to distribute negative 2 as the second factor to both the negative 4x term and the the 1 term from the first factor. And this is being, the term negative 4x and 1 in my first factor is being separated with a minus sign. So we're going to have negative 2 multiplied with negative 4x's. Okay, and then we've got minus, because of the minus sign that separated the negative 4x and 1, negative 2, our second factor, times 1. The second term in the first expression. In the first factor. Alright, so we've got negative 2 times negative 4 times x. Well, I know 2 times 4 is 8. Negative times negative makes it positive 8. And this is times x. So 8 times x is just 8x's. Then I've got negative 2 times 1. Well, 2 times 1 is 2. Negative times positive is negative. And then I have the negative that we had separating those two terms. Now, while 8x is a variable term and negative 2 is not, so I cannot combine them. However, we can rewrite minusing negatives or getting rid of negatives would make something more positive. So minusing a negative is really like adding. And I'm just going to choose to not write the positive 8x's. I'll just write 8x's instead. The positive sign would just be an extra symbol, and I don't want to communicate with extra symbols if I don't have to. Okay, again, this is just saying that negative 8x plus 2 is the exact same thing or equivalent to positive 8x minus negative 2. That's the exact same thing as negative 2 times negative 4x's minus negative 2 times 1, and all of that is exactly the same thing or equivalent to negative 4x minus 1 times, the quantity of negative 4x minus 1 times the quantity of negative 2. Okay, now I'm looking at number 8, and our goal is to distribute negative 8 to negative 2x's and also to negative 3, or to the 3. So I'll have negative 8 times 2x, negative 2x's. I'll also have negative 8 times 3. And the second term where it has the second factor that has the two terms inside of it, they were being separated with the minus sign. So now I've got negative 8 times negative 2x minus negative 8 times 3. Okay, I'm going to have to multiply negative 8 and negative 2x. I'll do negative 8 times negative 2 first. 8 times 2 is 16. Negative times negative makes this positive, and we still have the x there. So negative 8 times negative 2x is positive 16x's. And then I still have this minus sign. And then with negative 8 times 3, I know 8 times 3 is 24. And negative times positive is negative. Okay, 16x's is a variable term, and negative 24 is a constant term, so I cannot combine them. However, minusing a negative really makes something more positive. And I don't have to write the positive sign in front of 16x. Okay. So these are the notes. You'll turn this in today. You are turning this in today to the substitute. If anybody needs this pause so you can write anything down that maybe you didn't write down earlier, maybe you ask the substitute very nicely to pause this. Hopefully you guys have got everything figured out that you need to have figured out for those notes, or written down at least on your notes. Next, you will receive an assignment. It says distributive property riddle. There are 12 distributive property problems for you to simplify or solve. And this will create a riddle. So I will do one of them with you so you understand what I mean by it will solve a riddle. Okay. The riddle we're solving is, what did the 0 say to the 8? If I look at letter H, that's the first problem in the first row. We need to distribute 3 to both terms x and 2. And the x and 2 terms are separated with a positive plus. Okay, so we'll have 3 times x. We'll also have 3 times 2. And these are separated by a plus sign. So next we're just going to multiply. We have 3 times x, or 3 x's. We also have 3 times 2, which is 6. And there was a positive sign between those two terms. So anywhere I see 3x plus 6, we're going to put an h. Here's 3x plus 6, so this blank should have an h. Anywhere else we see a 3x plus 6, we should have an h. I don't think I see any more, but I'm quickly skimming. So if you see any other 3x plus h's, 3x plus 6's, you would put an h on that blank. And then whatever phrase you get here should solve this riddle. What did the 0 say to the 8? If you've got questions, comments, or concerns, I'd be happy to answer them. I normally tell you guys to shoot me a message on Schoology because I can still see my phone. However, I know you don't have your laptops, so hopefully you guys got enough from the video to help each other out, and I will see you guys all tomorrow.